Hello students, now in this lecture we see Cauchy's general principle of convergence and example on that. So what is Cauchy's general principle of convergence? So statement is a necessary and sufficient condition for convergence of infinite series summation un is that sequence of partial sum Sn, that means condition for series to become or to be it convergent is that the sequence of partial sum Sn that is Sn is convergent, that this Sn is convergent, then our series is convergent. We know this that convergence or divergence of the series depends on the convergence or divergence of this partial sum, that is this sequence of partial sum. So this is known as Cauchy's general principle of convergence. So for any series, if the sequence of partial sum Sn for that series, if it is convergent, then series is convergent. So we know this is known as Cauchy's general principle of convergence. Now here is a theorem, that is a series summation un converges if and only if for every epsilon greater than 0 there exists a positive integer m such that mod un plus 1 plus un plus 2 plus un plus 3 dash dash un plus p is less than epsilon for n greater than or equal to any integer m, and this p is greater than or equal to 1. So this is theorem, that means in this theorem we have given the condition for the series to be convergent is this modulus mod value of this is less than epsilon. So for given epsilon there exists positive integer m such that sum of these terms of series are starting from n plus 1, n plus 1 to n plus p. See here, sum of the terms of this series are starting from n plus 1 up to n plus p. That means here are p terms. This is first term un plus 1, this is second term un plus 2, and this is last term un plus p, means there are p terms. Sum of these p terms, mod value of this sum is less than epsilon for this n is greater than or equal to m. After m terms of the series, we get this inequality. So we have to prove this theorem. So for that, suppose the series is convergent series, then we have to show that this mod is less than epsilon. So if series is convergent, then above we have seen the principle of convergence, Cauchy's general principle of convergence. So from that, the sequence, if the series is convergent, then the sequence of partial sum, that is Sn, must be convergent. So here we have series is convergent, then this Sn must be, sequence Sn must be convergent. Now if sequence is convergent, then from Cauchy's sequence we know that if sequence Sn is convergent, then for given epsilon greater than 0, there exists a positive integer m such that mod, we write always mod Sm minus Sn. Here we have written Sn plus p minus Sn. This is less than epsilon, where this n is greater than or equal to m, and this p is greater than or equal to 1, so that we get from the terms un plus 1 un plus 2. So this is, since series is convergent, sequence Sn will be convergent. From definition of convergence of sequence, we can write this mod Sn plus p minus Sn is less than epsilon, and there exists such integer m. Now what is Sn plus p? Sn plus p means partial sum of terms n plus p. First n plus p. Sn means partial sum of first n terms. Similarly, Sn plus p means partial sum of n plus p terms. Therefore, this is equal to u1, u2, u3, u1 plus u2 plus u3 plus dash dash. Un plus p will be last term, and meanwhile there will be term un plus 1. These terms are in between u1 to un plus p. So Sn plus p means sum of n plus p terms. Sn is equal to sum of n terms, and here we want Sn plus p minus Sn. Therefore, this Sn plus p Sn plus p minus Sn is equal to subtraction. If we subtract this Sn from this Sn plus p, then the terms up to un will be get cancelled, and terms remains only from un plus 1, un plus 2, dash dash last term un plus p. Therefore, this is equal to un plus 1, un plus 2, un plus p. Therefore, mod un plus 1 un plus 2 dash dash un plus p this is less than epsilon if n is greater than or equal to m and p is greater than or equal to 1. From this our statement, so in 1 we have written Sn plus p minus Sn mod is less than epsilon when n greater than or equal to m and p greater than or equal to 1. Therefore, substituting this value of Sn plus p minus Sn is this, so we have written mod this un plus 1 plus un plus 2 plus dash dash plus un plus p is less than epsilon. So we have shown that the value of this modulus is less than epsilon. Now we see example. What is example is here. Show that the series summation 1 upon n does not converge. The series is summation 1 upon n. This series is not convergent. We have to show. So we use this above theorem to prove that the series is not convergence. So we use contradiction method here. That means, suppose this series 1 upon n is convergent, then we will show contradiction. So suppose this series is convergent series, then by this above theorem, if series is convergent, then this mod of un plus 1 plus un plus 2 plus un plus 3 plus dash dash plus un plus p is less than epsilon for n is greater than or equal to m and p is greater than or equal to 1. So what is our un? Un is 1 upon n. Therefore un plus 1 is 1 upon n plus 1. Substitute n by un n plus 1, you get un plus 1. So un plus 1 will be 1 upon n plus 1. Un plus 2 will be 1 upon n plus 2 plus 1 upon third term. Un plus 3 will be 1 upon n plus 3 plus dash dash plus 1 upon n plus p. So this is our values of these un plus 1, un plus 2. This will be less than epsilon by above theorem. Now here we choose epsilon is equal to 1 upon 4. Then this mod will be less than 1 upon 4 for n greater than or equal to m, p greater than or equal to 1. Now here we put n is equal to m. Here n is greater than or equal to m, so we can take n is equal to m. So n is equal to m, and we take here p also is equal to m. P is greater than or equal to 1. We can take any value greater than or equal to 1. So here we take for our convenience p is equal to m. So we put here values of n and p, then we get, now since values are positive values, so we need not write this absolute here. So we write here only, substitute n is equal to m and p is equal to m. So 1 upon n plus 1 means m plus 1, 1 upon m plus 1 plus 1 upon n plus 2 means m plus 2 plus 1 upon m plus 3 plus dash dash. Last term n is equal to m and p also is equal to m, therefore 1 upon m plus m. That means this m plus m means 2m. So this becomes 1 upon m plus 1 plus 1 upon m plus 2 plus dash dash plus last term 1 upon 2m. Now you see here that m plus 1 is less than m plus m. 1 is less than m. Therefore m plus 1 is less than m plus m. M plus m is equal to 2m. That means m plus 1 is less than 2m. If we take inverse of these two values, then this less than will become greater than. So 1 upon m plus 1 is greater than 1 upon 2m. Therefore here in this, here we have written this 1 upon m plus 1 plus 1 upon m plus m, this is equal to 1 upon m plus 1 plus 1 upon m plus 2 plus 1 upon last term is 1 upon 2m. So here each term, if we compare with this 1 upon 2m, then 1 upon m plus 1 is greater than 1 upon 2m. Similarly, one upon m plus 2 will be greater than 1 upon 2m. Each term 1 upon m plus 1, 1 upon m plus 2, 1 upon m plus 3, each term is greater than 1 upon 2m. So if we write, instead of this each term, if we write 1 upon 2m, then this side will be greater than this side. Therefore this is greater than this 1 upon 2m plus 1 upon 2m plus 1 upon 2m. Total there are m terms, 1 to m. M terms are there. Therefore these are m terms. So denominator of each term is here 2m. Therefore we can take addition. So 1 plus 1 plus 1 plus, this will be m times and divided by 2m. Therefore 1 plus 1 plus m times means it is equal to m. Therefore m upon 2m. Therefore m upon 2m, m get cancelled and this is equal to 1 upon 2. So value of this 1 upon m plus 1 plus 1 upon m plus 2 plus 1 upon m plus 3, this is greater than 1 upon 2. Greater than this 1 upon 2. And 1 upon 2 is greater than 1 upon 4. You know that 1 upon 2 is greater than 1 upon 4. Therefore this value is greater than 1 upon 4. But in above this equation 1 is here. Here we have shown that this 1 upon n plus 1, 1 upon n plus 2 dash dash plus 1 upon n plus p, this is less than 1 upon 4. Here particular value we have taken, that n is equal to m and p is equal to m. Then we get that this value is greater than 1 upon 4, where in this equation we have shown that this value is less than 1 upon 4. So this is contradiction, that the value is less than 1 upon 4 and we have shown that it is greater than 1 upon 4. This is contradiction. This is not possible. Less than 1 upon 4 and also it is greater than 1 upon 4. This is not possible. So this is contradiction, and this is due to our statement that summation un, that is series un, is convergent. This statement is wrong statement. Therefore we have to say that series un is not convergent, or it does not converge, and thus we have proved it. So we stop here.